In this tutorial, I am going to show you around the Coventry University Station remote laboratory. So here we are in the laboratory. The remote laboratory is hosted on a Raspberry Pi, which is connected to an Arduino microprocessor. The microprocessor has a motor shield on it, and the motor shield provides the drivers that we need for the devices that are attached. And in this case we have three devices attached. We have an LED, we have a DC motor and a stepper motor. So today I'll show you how to run some programs that will control each of these devices. To load a program up to the Arduino in the remote laboratory, you first have to load it into the window here in our remote laboratory interface. The minimum that any Arduino program has to have is a setup routine and a loop routine. And actually, if we load up a bare minimum as we've got shown in the window at the moment, that will have the effect of clearing any other programs off the device and setting the device back to a base level. But today we're going to have a look at three programs to control the actual devices that we have in the laboratory. To see the programs that are available, click on Examples and we get a drop-down list. You can use any of the programs that are to do with the devices that we have in the laboratory. So for instance, any program to do with the LED or to do with the DC motor or the stepper motor can be run. First of all, let's have a look at the blinking LED program. So this program turns on an LED for 1 second and then off for 1 second. So let's have a look at the code. Well, first of all, we declare an integer LED 13, and on the Arduino, pin 13 often has an LED connected, and we have that the same in this particular case. So then to set up, we say that the mode of the pin number 13, LED number 13, is output. So that means that the pin will take output and can send it to the LED. So that's the setup. And now let's move to the loop. And here in the loop you see we do a digital write to the LED of high. That sends a high electronic signal. Then we have a delay of 1000 milliseconds. And then we send a low signal to the LED and a delay of 1000 milliseconds. So that has the effect of turning the light on and off. So let's upload the program to see the effect. So now we see the light on for 1 second, off for 1 second, on for 1 second, off for 1 second. If we want to reset, we can just click on the reset button. When the light flickers on and off quickly, as you see now, it means that the code is getting loaded up to the Arduino. And now the reset code has been loaded, so there's no particular program running on the Arduino board at the moment. So let's have a look at the next program. We'll look at the DC motor test this time. So to affect the DC motor, we need to first of all include a library of routines for motors that's provided by the Adafruit motor shield library, and we have to declare the motor to be as an Adafruit DC motor. The 1 in brackets means that the motor is attached to port 1. And then we have our setup routine, and in this case we're actually setting up a serial stream to be able to send text for information purposes. And then we turn on the motor, we set the speed, and we say motor.runRelease, which sets the motor to idle. And then let's see what happens in the loop. Well, in this loop we're actually affecting a tick-tock movement. We're going to make the motor run forward, and it's going to be running forward, increasing in speed. That's what this loop here is doing. and then we have a loop which decreases the speed, and then we have the torque movement where the motor runs backward, increasing in speed and then decreasing in speed. And then for 1 second we set the motor on idle. So let's see the effect of this program. We upload. The light flickering on and off quickly means the code has been uploaded, and then we see the DC motor moving. Then it idles for a second, and then moves again. Forward first and then backward. So that's a program that operates the DC motor. Let's reset. And now let's have a look at a program that operates the stepper motor. So again, for the stepper motor we need to include the library, and then we declare our stepper motor. It's got 48 steps and it's on port 2. Again we have a serial output stream declared, and we set the motor speed. And in our loop, in sets, we're going to ask the motor to move forward and then backward, first of all in single coil steps, then forward and backward in double coil steps, then forward and backward in the interleave steps, and then forward and backward in micro steps. And each time we're asking for 100 steps. Let's upload the program and see the effect. So the code is uploaded, and now we see the stepper motor moving. First of all forward in single coil steps, and now backward. And now forward in double coil steps. And now backward. So hopefully you see the idea of how to load programs into the interface space and then how to upload them onto the Arduino. You can actually alter these programs to make the devices do different things, or you can write your own programs. In the next tutorial I'll show you how to change code and how to store it and reload it.